Hi, good afternoon, everyone. I'm Daphne from the Institute of Banking and Finance, and I'm going to be your host today. We're delighted to be partnering with Bizbaz for today's session on what and how AI technologies are used to ensure cross-border compliance and tackle money laundering. We are also honored to have Mr. Haik Hakopayan, CEO from Bizbaz, as our speaker today. Before we start the session today, I would like to share that if you have any questions, please post them using the Q&A function found at the bottom of your screen, and Haik will address them during the Q&A section. For those who may not be familiar with IBF, I would like to first give you a brief introduction on IBF and our offerings before I pass the time to our speaker today. IBF was established by the MAS in 1974 as a training provider to provide functional training for the financial industry. Since then, our role has evolved into one of the standards setting of the skills and competency of the sector. We also took on career advisory services, and since 16 October 2020, we are officially appointed as the Jobs Development Partners by the National Jobs Council to proactively work with firms to focus on supporting workers who are in job roles that are being transformed due to the wider adoption of technology in financial services. This is a quick look at our services and how we can support you across training, recruitment, and workforce transformation. You can find out more about our services and connect with us on any of these areas via our website. The COVID-19 pandemic has devastated global markets, and we are seeing a period of economic contraction. However, this is also a window of opportunity for companies to train and prepare your employees so that we are ready to accelerate growth when we emerge from this downturn. The MAS and IBF are here to support the industry. You may wish to tap on the enhanced training support, which is part of the MES support package to sustain and strengthen capabilities in the financial services and fintech sector amid the current economic downturn. The aim of the enhanced training support is to encourage more training and prepare for the accelerated growth when the threat of COVID-19 recedes and more economies open again. For the rest of this year, we have raised training funding to support to 95%, subject to prevailing grant caps. The funding quantum will later be reduced before going down to pre-crisis level in 2022. Hence, this is really a good time to look into your upskilling needs. You can find more details on the enhanced training support on our website. You can also find eligible training programs on the IBF Program Finder on our website. IBF will further supplement the commercial training available with our free webinars like the one that you are attending right now during this period to support the training needs of the industry. In addition, you can also tap on Learn at IBF Learning app for bite-sized learning at your own leisure. With that, I've come to the end of my presentation and I'll hand over the time to our speaker from Bizbaz. Please be reminded to post your questions using the Q&A function found in the utility bar of your Zoom interface, and Haik will address them at appropriate juncture. Haik, over to you.
Thank you, Daphne. Hi everyone, good afternoon. Let me start by sharing my screen. Tell me if you can see my screen clearly.
Yes, we can. Thank you.
Okay, great. Thank you. Okay, everyone. So today we're going to talk about AI a little bit and then address compliance and money laundering and how that's working out in general. And we'll have two case studies. So one would be with UOB and one would be with DBS. I'm conscious some of you are from either of those banks. Just before we start, just a couple of disclaimers. Apparently, as you realize, for me to do an AML basics or foundations kind of primer, that will take quite a while. So I'm gonna go on an assumption that most of you or all of you have basic knowledge of what's AML or what is compliance, generally speaking. And I'll focus and spend more time talking about AI or ML machine learning aspects of things. And as Daphne said, please feel free to ask questions. And if there is something very, very technical that I'm unable to respond right away, feel free to connect and we can take this offline and discuss offline. Okay, and let's start. So just a little bit about me. The person on the right side is me. I'm Haik, co-founder, CEO of Bizbaz. We offer financial intelligence products, headquartered in Singapore and operating in Southeast Asian countries such as Philippines, Vietnam, and Indonesia. Before this, I was part of a couple of multinationals, including Vonage Group, Tagwork, and HP, and I've been advising in AI and behavioral sciences since 2011, so it's going to be about 10 years. Currently based in Singapore. Right now, I'm in lockdown in London, but generally based in Singapore. And that's a little bit about myself. Here's a little bit of an agenda that I put together. While I assume that you all know some things about compliance and AML, I'm going to assume that you know pretty much nothing about AI or ML. So I'll try to start on a level of just giving what's what in AI and basic definitions so that everyone is up to speed on that regard. Then we'll talk a little bit about the myth, so some of the AI myth, because this is very common. We see this a lot when banking or insurance executives talk about AI, but they don't really have a good understanding of it. So just to understand what's a myth, what's a reality, and then we'll dive right in terms of finance. So what type of AI is used in finance, and then we'll of course look at compliance and ML related usages. Very importantly, we'll dwell on and talk a little bit about risks in general, and we'll spend about half of this presentation talking about, well, EOB and DBS case studies, I think. So there'll be plenty of time to see specifically what the two banks did and what were the results. And then we'll finish off basically with some recommendations and some names of frameworks and tools that you can take away and check and potentially use if you're not using already. Okay, so basics, what's an AI? Let's start with from very beginning. So artificial intelligence is basically an area that is now very, very trendy. If you type in Google AI, you'll find a lot of articles. However, this field actually started back in 1956, and the term artificial intelligence was coined by Marvin Minsky, who is also considered, among others, one of the fathers of artificial intelligence. In 1950s, 60s, as you know, was the era or period of time when computers, mainframe computers, were coming on board. So from the very beginning of that time, what Marvin Minsky had in mind was that if computers could do some of the human tasks, would it also be possible to basically create a system that would offer human level intelligence to computers, not just to do mundane repetitive tasks, but also some intelligent tasks. And hence, that's one of the reasons he named it artificial intelligence, because humans were the natural intelligence and computers, which were again at the time a novelty, will be considered the artificial or non-natural intelligence. A very common thing that, again, we see a lot when we're talking to generally banking or insurance executives is a common kind of sometimes people just mix up ML and AI, artificial intelligence and machine learning. So I think it's important we kind of start really clarifying what those things are and what are the differences. So AI generally, as I started saying, is about training machines or training computers or algorithms to do something on a more intelligent level, whereas machine learning has to do a lot more specifically with data-related tasks, not necessarily very high-level, human-level intelligent tasks, but things such as segmentation, things such as data analysis and predictions based on data analysis. And again, if we look again at the left side, right, so you'll see that some of the differentiators of AI from ML are that some of the AI is able to a certain extent, simulate some of the human tasks, whereas the aim of ML is a lot more to improve data-related performance of a task. AI, and I think that's probably one of the most important things on this slide, is that AI includes machine learning and deep learning. You can say that AI is a kind of a superset of machine learning and deep learning. So machine learning is part of AI. It's a very specific data related part of AI. And I think a crucial differentiation is also that while AI is focused on improving the success of specific tasks, machine learning is usually, as a part of it, is more focused on improving predictiveness or accuracy or data analysis, again, related metrics. AI can be divided into three kind of generic buckets, right? Strong AI, general AI, and weak AI. Examples of weak AI would be, for example, Siri on your iPhone, or some of the, for example, Google Translate could be potentially considered a weak AI because, again, you're translating. There is an AI used to translate between different languages. That's a weak AI. General AI is considered a level. So strong general and AI is considered compared to human intelligence. So weak AI is considered basically weak, equivalent of a weak or primitive or simple human level. General AI is what we are basically, if you're looking at news, etc., every company is trying to have a more general level of AI, but we are still not fully there. And strong AI is considered the super intelligence, basically an artificial intelligence system that can act on a superhuman level. So we don't yet have such a system, and you probably know that Elon Musk and a lot of other big tech entrepreneurs are afraid of having that level because they think that potentially AI can take over human systems as well. So we are not there yet, and I think it's not even realistic to assume that we'll be there anytime in the next 10 to 20 years. So if, again, that's AI, strong, general, and weak. And if you look at machine learning, you find, again, like very generic buckets. There is, of course, more granular categorizations, but we would call those supervised, unsupervised, and reinforcement learnings. This is the three kind of main types of machine learning. And of course, again, from data perspective, if you look at it, AI will deal with pretty much any data. So whether that's a unstructured data, structured data, or semi-structured data, and machine learning, because it is very focused on data related, as I said, segmentation, analysis, and predictions, it would mostly deal either with structured data and or semi-structured data. And a brief definition of what's a structured versus, let's say, unstructured data. Structured data is the data that's clearly labeled. So as an example, you take a photo and it's coming with a label that this is a cat in a room, right? Or it's a cat at least. That would be a structured type of a image because it clearly denotes or it describes what the image is supposed to comprise. Whereas unstructured would be basically it's an image and it's up to a machine learning system or an AI system to figure out what is on that image. That's the basic difference. Again, on the right side, just again very quickly, AI applications versus machine learning applications. So if you look first at machine learning, so data-related tasks mostly, so segmentation, classification, or categorization of data. And then you very commonly, I'm sure most of you or all of you heard things such as, for example, back testing or analyzing historic data and then predicting life or future outcomes. So this is a lot more related to ML applications, whereas AI is more related to a higher level tasks in that sense that deal with some of the data analysis, but they are mostly related to, for example, computer vision or image recognition or natural language processing, or sometimes even recommender systems such as the ones on Amazon and some other systems. So just this is a very quick overview. Again, not trying to be very exhaustive here, but just give at least some basic notion of differences of AI and ML. Very quickly, a recap of where AI is most used. I think this is very useful because, again, due to the fact that this is a very trendy concept, many people think that AI can be used pretty much anywhere. And theoretically, they are right. But if you look at the current usage, you'll see that mostly AI is used for IT related activities. So 44% of those surveyed use, so these are basically C-level, VP level executives from across the world. This is a survey conducted by Harvard Business Review. And as you can see, 44% of the use cases of AI is in detecting and deterring security interactions. So this is in some ways also including the topic of our discussion, anti-money laundering. And of course, the rest of the breakdown, as you can see, has to do also with technology problems or work automation or reducing production related issues that are more manual. So this, again, I think the takeaway here is that it's mostly used in IT. And if you look at specifically finance or in financial sector, 70% of respondents basically also show that they are using it for high frequency trading. That's another application of AI in finance specifically. Okay, so having kind of set the context or at least aligned everyone on kind of basic concepts, let's talk about what AI is not supposed to or is not supposed to be or what it isn't. So these are all kind of AI myths. We hear this in webinars, in discussions. We see sometimes articles that basically articulate some of this, right? So just want to make sure you understand that these are basically myths. So number one, the fact that AI can be basically bought. It's like an off-the-shelf product, if you like, or ready product, and it can be kind of bolted on your existing, whether that's in our case, compliance related or AML related framework, or it's another application in the finance industry. You can basically buy something, use it. It's a bit like a mobile application. So this is a myth. AI systems, as we'll see in a second, they require a lot of customization, even the simplest ones. And they require a lot of feedback, and they are not as simple as just another online product that you as a bank or you as an insurance company can get and readily deploy. Of course, there are some exceptions for very specific use cases, but by and large, it's not true. Another thing that we see more and more, especially now, we are seeing this trend come up in Singapore and Southeast Asia, that, okay, we as a bank need to have an AI strategy and we need an AI manager. So this is also, if you like, a myth. This is not for sake of, AI is not something that you have to have for sake of having. It's more to do with what your overall business or product strategy is and how AI would fit into that. And of course, if there is a product strategy that includes AI related activities or focus, then you do probably need to have someone who is in charge of coordinating those activities. This is also something that we hear, strangely enough, point number 3, AI technologies define their own goals. Sometimes, again, especially in the banking context, we see that the discussion goes into, okay, we will implement some sort of an AI system for, again, whether that's related to specific product or specific strategy. And then because there is an AI, there are specific implied goals that we have to achieve. No, guys, this is also a myth. AI is just a means, or it's a technology, just like any other technology. And it cannot be defining its own goals. AI is good when you have lots of data and need automation. So this is only partially a myth in some ways. I would go on a limb and say, the more data you have, the better the chance that you'll have a better AI. This is in a sense correct, because many AI systems use data to train, to customize, to be customized and to improve themselves. So as such, there is a need for a lot of data. However, again, just because you have a lot of data, that does not imply that your AI systems in place will be performing well. AI will do better than humans. This is also a myth. Again, this is a very trendy term now that everyone is rushing to have some sort of AI system, especially, by the way, in IT-related tasks, as you saw from the survey. And everyone thinks that AI, for example, in anti-money laundering, as we'll see in a second, there are some companies that are literally thinking of replacing their analysts or their specialists with AI products. While it is basically a decision they can make, the best approach is so far proven to be hybrid systems, basically human in the middle systems, as they call them, whereby AI is providing specific expertise or insights into data, but it's the human who makes the final call, or at least provides an input whether the decision by AI is correct or not. So there is that part. So AI is not a panacea, or is not a solution to all, or it doesn't necessarily even perform better than humans. AI will take over human jobs. I'll not dwell on this. I think, in my opinion, that while AI, of course, is automating a number of jobs that would be otherwise very repetitive, but then at the same time, AI also creates a lot of jobs that didn't exist before. AI is only good at automation data processing. This, again, is a misconception. AI is indeed good at streamlining or automating many repetitive tasks, but in many cases, it is not just a repetitive task that AI can do. AI and ML are both employed especially for analyzing data. So this is one of the main aspects of using AI. Analyzing data and coming up to some actionable or some relevant insights, tasks that humans could equally do, but they would take probably a lot longer time to do the same task. I just talked about AI not being the same as machine learning, point number 8. So AI includes, among others, machine learning. And we hear now more and more, because of some of the news related especially to reinforcement learning methodologies, that AI is more important than data. Of course, pretty much every company that starts off initially not having any sort of AI or ML system, they don't necessarily have structured, labeled, clean data. So for them, they always say that, well, if we have AI, then it's more important than data. That's also a myth. Usually, AI systems, as I said earlier, require data to train, to test, and eventually to run smoothly. So again, there is a point of not discarding data just because one has AI systems that one is using. And as I was saying on strong AI, the last point here, strong AI, superintelligence is the strong AI. There is, of course, a lot of fear that this is impending. I think if we can little bit extrapolate history, I would probably disagree that superintelligence is years away. If there is strong AI or superintelligence that's coming, that's going to be, my guess, 10 to 20 years at least away. It's not something that will happen soon. And yeah, I think we always underestimate. So my guess is it's probably, at least, as I said, 10, 20 years. Okay, so kind of done with a bit of a primer, if you like, on AI ML. Hopefully everyone is on the same page and what is not AI, where it is used. So let's dive a little bit into AI usage in finance, and specifically in AML and compliance. So this is basically info from Europol report. So today, money laundering activity around the world is estimated to be between 2 to 5% of global GDP. While 2 to 5% in itself doesn't sound like a big percentage, but if you look at global GDP that runs in trillions of dollars, this is a huge amount of money. So huge amounts of activities are taken place illicitly, illegally, and using money laundering to move cash, capital, or money, or trade. And I think the staggering statistic is that also just around 10% of suspicious transactions reports filed by financial institutions lead to any kind of further investigation or full understanding of what really is happening. So it's basically some sort of I don't want to say dark web, but it's basically a lot of this illicit and illegal activity does not even get reported, and when reports are filed, most of it is not even investigated properly. So that in itself is very staggering, very shocking, the fact that there is all this and still there isn't much done about it. Um, current so current AML systems, right? If we look at anti-money laundering systems, they normally look somehow like this. Again, this might differ slightly from bank to bank or from insurance company to insurance company, but this is more or less how it works, right? So let's just go a little bit through this. So you get some data. So let's assume, let's take some examples, right? Let's say there is some sort of a transaction, right? So data. So start from the left side. Data comes in. If there is an AML system or some sort of a check and balance system, if you like, that is looking at specifics of transaction to make sure that they are not illicit or illegal or fraudulent. Then you of course have a part where, again, not going into all the small details, but there is a part where basically data is analyzed, is segmented, right? And then of course the common practice employed by most of the banks is that they have some sort of rule-based system. So there are a number of rules, and basically the data is subjected to this algorithm that looks at different rules and makes sure that it checks out, right? It is basically the rules are not marking it up as some sort of illicit or illegal or in any way against the law type of a transaction. If, however, the data doesn't pass this check, right, if the triage and scoring results in some sort of a red flag or alert, then as you can see, alerts then are moved and categorized into different types, L1, L2, L3, and then eventually, once the system kind of understands and scores those different alerts, you have a suspicious activity report coming out of it, SAR, suspicious activity report. And that report is sent to a specific part inside the organization, inside the bank or insurance company, which then decides what to do with this transaction, or which then decides to proceed or follow up or not with this transaction, right? This is kind of a standard approach. Now we are seeing more and more banks and insurance companies thinking of a more holistic implementation here. So the difference between this and this is that this is very linear and goes in one direction. Basically, data comes, gets analyzed, rules are triaging and scoring different types of transactions on data. Alerts come out of those, and then as a result, there is some sort of investigation, and then there is a suspicious activity report if there is still something. This newer approach is more integrated, if you like, whereby it's a feedback loop. So the data continuously flows into the system. However, as you can see from different categories here, the AI is analyzing both. So there is a contextual analysis, whereas the previous one usually would just have basically based on data or transactional information. Here you have profiles, right? So there's a context of, for example, who is the sender, who is the receiver. So it's not merely data. There's a specific context. There is more information about the entities who are transacting. So there's a KYC done. There are already potentially red flags or not in terms of, for example, adverse media mentions or any kind of litigation or bankruptcy related information. All of that will be related or tagged to specific profiles. There are, again, the data gets compared and analyzed against different types of links. So on the bottom left, so whether that would be, again, links being anything from account links to legal entity links to, again, different counterparts. Again, there is more contextual analysis here. Counterparts meaning, for example, if there are previous transactions, etc., that would be more common. Those counterparts would also be analyzed in that context. And of course, with the advent of social networks, etc., considerations about someone's social network are also somehow considered. The AI basically looks at data with this more holistic contextual type of analysis, as opposed to looking only at zeros and ones, if you like, or just purely transactions. And then based on that, on the right side, as you can see, if there is a suspicious activity, coming out of that more holistic analysis of transactions, then that activity, of course, gets analyzed also on a more holistic level, not just purely on rule base, which is the mostly current systems that are doing this. So it looks at, for example, if there is potential suspicious activity, what's also analyzed is, for example, the context, such as, for example, the device, if there have been, for example, any recent profile changes of one of the entities transacting, has there been any kind of a peer activity, or has there been any other suspicious activity that can potentially be tied up to current activity. And of course, as a result of that, rules are of course again still used, but again there is more holistic analysis to understand what could potentially be happening actually here. And of course, if there is a suspicious activity, then the report will be created and filed and processed as it would be in a current situation. So this is basically a more holistic, as I said, approach. The bigger difference here is that contextuality and intelligence is added on top of this otherwise linear system that just goes from one side, data, and a suspicious report comes on the other side. So this is how it should be. This is where AI is value adding tremendously, as opposed to just purely having rule-based AML or KYC system. So a typical process, this is not necessarily just for compliance, but as an example, AI for compliance or AML, the system, the way it would work, right, as we started discussing, would be that initially the machine, or let's call it algorithm or machine, they will be basically self-teaching, right? And the process using historic data. So pay attention, it says historic data. So for AML and compliance, normally AI and ML systems, and mostly this is ML systems that are used for compliance or machine learning, for compliance or ML, mostly they require some sort of historic data because they need to be trained. So and then step number two, so of course at step number one, it's great if the data is structured. As you recall, just now we were referring to structured data, meaning labeled data. So if you have specific transactions, historic transactions, or historic data, ideally it is labeled. Ideally, in most cases it's not, but ideally it has tags relating whether that is indeed a suspicious activity or it isn't, for example. Then as a step two, of course, humans fine-tune the initial learnings, right? So machine learning is back-tested or tested on historic results. And then human specialists, so AML specialists, they basically look at the results, see that the outcome and prediction on historic data is exactly or with a high confidence interval correct. Once that is done, the point number three or step number three is that then the system is launched live, normally on some sort of a small sample or a pilot test, to see that the same system can, after fine-tuning at step two, can also analyze and provide alerts and monitoring of real-life data. And then again, at that stage, normally you would have humans who are human specialists who are again analyzing in real life the same data and making sure that what the machine learning algorithm or the AI algorithm is showing is correlated with their own conclusions and outcomes. Again, to make sure that the system or the machine is still on track. And of course, that's feedback to point number three. And this is basically a continuous kind of a loop. Points number 4 and 3 kind of continuously improve themselves. So this is again, as you see from step one or from the beginning, you don't have a system whereby you launch an AI, there is no human intervention, there is no feedback loops, and it by itself, even with the labeled data, basically learns and does the thing. There is always a need, at least for now, to have human specialists to check the results on historic data, then on live data, and make sure that systems perform. So some of the things why AI is used, for example, in compliance or AML relate to those sectors. So one of the main reasons that AI systems are used in compliance and AML is to reduce false positives. A definition of false positive is that you have data that was tested and it yielded a positive result, means it's suspicious. However, it's false, right? So it's not suspicious, but it was falsely marked as suspicious. As you can see, so there are estimates, and I'll share the deck after the presentation. You can click the links inside. But as surveys show, AI is able to reduce false positive ratio by an estimated 20 to 30%, which again is a significant improvement. As we started saying when we were talking about AI in general, AI or ML, I mean, just to clarify, I'm now just using the term AI, but many cases this is machine learning. AI systems are used for continuous monitoring of transactions and of data. This is simply because there's usually, especially a bank of any size or insurance company, they do have significant amounts of data and transactional flow, and AI systems are deployed to make sure that to basically automate some of the analysis of the data. And AI enables better decision making, right? I think I started saying that AI can analyze a lot bigger amounts of data in a lot more detail than humans can on average if it's custom and well deployed system. So that's one of the reasons they are used. And I think very important is, and again, we hear this a lot every time we hear AI, there's always word regulation or data privacy or data compliance also coming into the same discussion. So regulators such as the UK's financial authority are neutral, right? And the same thing, I think, now also in Singapore, the authorities are basically cautiously monitoring the inflow of new AI systems in finance. One aspect that's very important to mention here is that AI, as we started saying in the mid part, is not some sort of a solution for all or a magic button. It doesn't matter what AI related ML system you are using or you can use, it will always require a lot of customization initially, then testing, then running it on a small live samples or pilot mode before fully really deploying the system. And you'll see in a second when we talk about, for example, UOB or DBS use cases, DBS took about 2 years to come up with their own AML system, 2 years just to implement and deploy it in live production. And of course, I think I'm dwelling on this, but this is important. Don't underestimate the task of data preparation. So you recall how we were just talking about structured and unstructured or semi-structured data. So what we see is also a number of banks or financial institutions, they have the appetite, they have the innovation departments, they are trying to implement AI systems. However, the big thing they neglect is the preparation of the existing data and the systems that generate this data. So what we see is they go in, they get some tool or framework that is supposed to be, for example, for anti-money laundering, and they lack the part where they understand that they have to ideally provide structured data, or at least semi-structured, which would be at least somehow labeled or somehow rendered more intelligent to an ML system. This part, guys, I'm dwelling on it because this is very important. Without ideally structured data, it's very, very difficult even for custom AI systems or machine learning systems to take off the ground or to perform well. As mentioned here, research by Accenture shows that approximately 90% of time, people who train AI applications spend preparing data and feature engineering. So I cannot overemphasize just how important it is, the data preparation part. As you see, before and during the time of deployment of AI, most of the time is spent on data. related activities, whether that's labeling data, doing feature engineering, or doing post-deployment analysis to understand what's happening. As mentioned before, machine learning is a double act with humans playing an important role, right? So human in the middle approach. So there mostly AI or ML systems that are used are still not at the level where they can autonomously start analyzing data and basically yield results that are congruent or consistent with the best specialists. So you always need double checking and humans to perform kind of a correlative or corrective actions to the ML algorithms, whether that's from the algorithmic perspective or whether that's from a specific feature related perspective, whereby specific, that's the term also related to feature engineering. And as mentioned, again, there are a lot of risks. Again, I spend a lot of time on kind of emphasizing risks and kind of cautionary points, but this is also very important, and not enough attention is given to this. But the risks need to be managed with care. So again, a global study conducted 2 years, 1.5 years ago by a Bank of England and the Financial Authority showed that there is a rising awareness about the risks that AI can pose, and in financial systems as well as anywhere else. So if you look at it again from more specific AML perspective, what do we have? And by the way, I'm including a lot of this text with the assumption that you'll be going through slides and reading afterwards, hence more text is inserted into the presentation. So machine learning algorithms, as we started discussing, can detect and recognize suspicious activity or behavior and risk rate them, right? In any anti-money laundering related activity, you do have flows of information, and everything in some ways is probabilistic, right? Data is probabilistic as such. The certain amount of data could be risk rated to be, I don't know, 60% suspicious or 40%, depending on the context, on the type of AML system that is deployed. So of course, with some exceptions or besides some cases, most data is not black and white, suspicious, not suspicious. Some data could potentially be suspicious if you do a more contextual, larger type of analysis, right? And as I said, most traditional systems, they use rule-based AML approach, whereby you have specific rules that are specified and each data basically is subjected, or each transaction is subjected to filtering or triaging by these rules to ensure that it is legitimate, it is a correct or allowed type of information transaction. So in traditional systems, as I said, traditional systems detects very specific kind of types of data because there are rules that are analyzing the limited number of rules. And the results of those rule-based AML systems are that there is always some sort of a noise, right, that is generated, because the idea is that rules are usually, you don't have big number of rules, and as a result, you don't want to potentially exclude transactions that are that could be legitimate but are not, based on some rules. So what some of the rules are they are more loose, if you like. They are casting the net wider in order to not miss anything. As a result of that, there is a lot of noise that's coming in. So a lot of activities or a lot of transactions that would otherwise not be filtered out are getting some sort of a risk rank that is probabilistic, but it's not very informative. There is noise in it. And of course, as it says here, once you are relaxing a little bit these rules, then you can also capture potentially suspicious activity, but it will be perceived and analyzed and ranked close to a normal activity. So that's not necessarily a good outcome. So one approach here is to train. So if you're starting to use not just a rule-based model, but you're trying to include more and more of AI, then you can train your systems to look at not just from a rule point of view, but more behavioral point of view, more contextual point of view. And of course, as I said, some of the use cases that we now see is also ML being applied for things such as name screening. As you recall a couple of slides before, a name can be quite informative if it's looked at the larger context, the futuristic or the kind of up and coming scenario that we showed. Every transactional data is analyzed, including name, is analyzed not just as its own, but it analyzed in the context of links, in context of former counterparts, and in context of a generic profile of whoever that name belongs to. And there, that's where that's what now number of banks are doing. But again, the challenge there is that because of that more generic analysis, there is always a balancing act of accuracy. So balancing the fuzziness, because you get a lot of contextual information with accuracy and specific result. Using ML, for example, point number 4, using ML to improve the matching criteria, right? So rules are usually there to match specific data and risk grade them, whether this, for example, suspicious, not suspicious, or what type of data this is. So ML can be applied to the same thing, basically. And as a result of the fact that ML can also do more holistic analysis, again, the efficiency of overall name matching or matching criteria can improve tremendously. Because again, analyzing a contextual type of analysis where it looks for counterparts, different links, the KYC, it can reveal a lot of kind of hidden links and things that otherwise a normal rule-based system is not gonna reveal for you. One big issue here is also that AI systems are in some way black boxes, if you like. There is what they call an explainability problem. So AML system, AI-based AML system gives a result for sometimes for analysts or AML specialists, it's difficult to explain why that result why the model or the algorithm came to that result. So this part of having explainability is becoming now more and more paramount, and there are a couple of kind of frameworks that are now being implemented in order to make AI systems used for anti-money laundering more transparent, more intelligent to us humans as well. Again, feel free to afterwards kind of look at those frameworks. And again, like just kind of on a more visual level, general process here and the risks associated, right? So on the top side, you see the general process of, as I said, how the AI deployment for AML systems would work, right? You have an input of the data on the left side. Initially, you have algorithms that are basically looking at the data, right? So, and then algorithms are tuned or customized based on historic data. And then the outputs are, so once the systems are customized, the algorithm is fine-tuned and yielding consistent results with the historic data and the historic outcomes, then the live deployment happens. Now, how, in this three-step process, right? Input data, algorithm design, and output decisions. There are always risks associated with these three, right? So if you look at it, so input data is vulnerable to risks such as biases in data. I'm sure some of you or many of you have heard how, for example, a number of AI algorithms are designed and trained with white people as let's say with white people related characteristics or behaviors, and that doesn't necessarily apply to different Asian, for example, characteristics or behavioral patterns, right? And it's not just related to race or ethnicity, it's also data can have other problems, such as, for example, more information or more of it, for example, related to a specific age. So it could be biased in different ways. related to, for example, age. It could have other characteristics that are not necessarily representative of the overall sample. Algorithms, they can have their own risks associated. Again, same thing. There could be problems with logic, problems with assumptions related to data, related to algorithms, judgments, right? Because algorithm is where the analysis and prediction or decision happens. So there could be potential mistakes there. And of course, at the end, the risks are also associated with the output decisions, right? A lot of data, as I said, especially in rule-based systems, could be interpreted in different ways. So interpretation in itself could be a problematic thing as well. So again, below are basically different types of data associated, the different types of risk factors associated to both data, algorithm, and output decisions. I think these four are probably the most important categories. Human biases, cognitive human biases are basically biases which what I call are behavioral flow or behavioral design features that we have. So we are all, for example, prone to things such as endowment effect or status quo bias, etc. Endowment effect is the fact that once we think something belongs to us, we in our head we think that the value of that is higher than in reality it is, and we are reluctant to part with it. So we ourselves have different biases. The problem is that when we act or when we are developers or use ML systems, design ML systems, some of these biases that we have are somehow becoming part of the system that we design or we interpret. Technical problems or technical flaws, right? As I said, there could be some problems related to algorithms, both in terms of validating the historic data, as well as decisioning afterwards on live data. Flaws in terms of usage of algorithms. This is also a very critical point. Because it's one thing when you're training a standalone AML system on data, it's another thing when you're integrating AML systems into a larger banking or underwriting systems. There could be different considerations that are not taken or not accounted for, and that in itself could also provide some risks. And of course, last but not least, is security related. AML systems, just like any other piece of software or system that's deployed by banks, are vulnerable to security flaws, different security flaws. As I started saying, explainability or interpretability is also an issue, among others. That's a pretty big or important problem that a lot of decision makers are now talking about. And the reason for that is because increasingly we are deploying AI and ML systems when it comes to critical data analysis, whether that's everything from remittance between two people to large trading data analysis between multiple parties. And the problem is that AI in many cases is able to take in data, and even the best of them are giving a result, but sometimes the results are not easy to interpret or explain by human specialists. And this is becoming, again, a strong consideration for using, as I was showing a couple of slides ago, there are different recent frameworks that are now recommended to be used in order to make the data more in order to make both data as well as the performance of a AI-based AML system more explainable. And of course, we just talked about AI biases and how they are sometimes, because a lot of AI systems are done with characteristics and behaviors of, let's say, Western or specific type of people, and they are not generalizable. They cannot be generalized. I just mentioned also a couple of slides ago that there is a consideration about regulation and data privacy or protection when we're talking about AI. So GDPR across, I mean, GDPR related, GDPR has probably the more mature AI related considerations as of now. So across all EU states contains provisions dealing specifically with automated decision making. And of course, there's Article 27 as part of GDPR that prohibits any entity from carrying out fully automated decisions that can have legal or other significant implication or effect on people. So as you see, it's legislated. Basically, it's on a level of law that we, at least as of now, cannot trust fully an automated or AI-based system. At least for now, we cannot trust, simply because the systems are not at the stage where they can act fully independently. Now, I think a lot of this was conceptual or in some ways theoretical, giving information. So let's look at some use cases, if you like. And just before we go into specific, as I said, UOB or DBS use cases, let's look at, so FICO, the American Credit Bureau, has conducted a survey, a recent survey, this is 2 years ago, I believe, whereby they looked at 73, they looked at Southeast Asia and Singapore specifically, the banking or financial sectors, and tried to analyze and gather more data related to financial crimes or money laundering activity. So this survey showed that 73% of Singaporean banks believe that AI will strengthen AML efforts, but they are not really sure how to operationalize or how to action those. And of course, I think by now it should be clear for you, the optimal approach is to, of course, use both AI systems as well as to combine, number one, AI systems with some rule-based approaches, which are normally what most of the companies use, and also have human specialists who will be supervising AI activities, or at least the results of those algorithms, at least initially. As you can see, the biggest percentage of why, if you look at the chart here, the key challenges in achieving financial crime, challenge number one to kind of achieving the financial crime objective is the speed in responding to new financial crime threats. That's simply because normally the threats are not new or are in some ways not accounted for or difficult to catch or risk rate in existing systems, and hence that's probably one of the main reasons why this is so highly ranked. Of course, I think second one is the more pragmatic reason of just high detection for any suspicious type of activity. And of course, some of the challenges have nothing to do with actual business or financial crime related objectives, but they are more administrative, such as, for example, lack of overall business buying controls and requirements, or lack of tech innovation, etc. The other chart here that's interesting is what are the key drivers of financial crime strategy for banks. So these are the key drivers. Again, if you look at the top, you will see that the key factor is impact for financial crime management on customer experience. So apparently customer experience is one of the larger or bigger considerations when it comes to financial crime strategy. And of course, the other significant ones are obviously things such as financial losses to your institution, because as you recall, we started off saying that 2 to 5% of global GDP is lost on money laundering or illicit activities. And that, of course, on the level of a bank, that there is a significant impact for the bank as well, for each bank. So over 2 in 5 respondents ranked this in their top considerations, with 70% of APAC banks citing as the primary factor their current and future approach, basically customer experience. So I think that this is very important. So to me, when I read this research, I thought this was in some ways counterintuitive. I would imagine the first or the most important thing for a bank would be to prevent potential losses or regulatory considerations when they are thinking of using AML or AI for compliance reasons. But that's on the same level as customer experience, which is quite an interesting observation. Okay, guys. So some of you are from UOB. Feel free afterwards to provide some opinions, or if you are directly involved, you can also share your comments or again opinions, or correct me if I get something wrong. So again, the links to this case study are in here. As you see, UOB is highlighted. We'll share with you afterwards the deck, and you can read the entire article, the entire document for yourself. So in this case, basically, I mean, UOB, which is one of the larger regional banks, which has a big presence in Singapore, decided that they wanted to use an AI system to for basically accelerating their fight, if you like, against money laundering. They have, well, previously, before that, they've established FinLab, which was the, if you like, the R&D part or accelerator / R&D for the bank. And then FinLab, of course, picked up one of the RegTech companies called Tukitaki in Singapore and collaborated with Tukitaki to come up with a custom AML system. Let's see specifics of this, right? So UOB initially started off by creating some sort of a sandbox environment. As I was mentioning just earlier, it is very important to, number one, backtest as much as possible on some historic data. And the second stage after this, it is, of course, to test or pilot it. So sandbox will be used for testing or piloting such a system. And then UOB, of course, named their own system anti-money laundering suit and took the initial framework that the bank already had that would include things such as KYC, transaction monitoring, name screening, etc., and try to have a more holistic, as I was showing earlier, approach. So this is how the design was done. So you can see the AML framework above, and you can see the different components as we were discussing. So part of it will be the design customization of the system to be tested and to be tested on historic data and then on small sample. So that would include machine learning models, data analysis and processing. The second part will be, just like any bank, UOB has different types of applications or products. So that would be plugging this system into transaction monitoring systems across different products and then checking payment related also transactions. And last but not least, it will be some sort of management on dashboarding part whereby data and the results of processed data could be analyzed, and suspicious activity reports would be logged in here, and the overall performance of model could be analyzed and improved. So based on this AMLS system, as you can see, it has multiple touch points, which might or might not be obvious, but user apps part would be, among others, part where also multiple other products could be plugged in. So as a result of the AMLS framework being deployed, the predictions would be passed on, for example, for transactions to different bank systems and products. And then as a result of that, a decision would be again made. So there will be different types of alerts rank rated. And then the decisions about this would sit in data lakes, right? Again, data lake, as you guys know, contains different types of data. So operational or external data or internal data. And then again, AML system would extract specific decisions. This would be for training and improvement purposes for its own self, as well as continuously supplying predictive predictions and alerts to different parts of the banks, whether that's, as I said, everything from remittance to trading data. So AML system in that sense is plugged at multiple touch points of different products and acts on a more infrastructural level in a bank, acts on a similar level or close to the level of the core banking, whereby it flags out and analyzes data. Here is a more of a schematic in terms of how it looked like for UOB. So you can see the Tukitaki system deployed right in the middle. So Tukitaki is a RegTech company that allows AML, that provides AML systems that could look at and work with both supervised and unsupervised learning. So data will be input into this system that was customized for UOB. And as you can see from the top, customer profile, transaction profile, and historical alerts. So customer and transaction profiles would be both considered. Tukitaki would analyze, again, based on rules, as well as, again, using AI systems for clustering and categorization of data. And as a result of the analysis, they would score different types of transactions into different alert rankings, and pass that information to the prioritization system, alert prioritization system below. And based on that, again, the system would look at higher probability alerts, and that will be marked and passed on to the investigation, so on creating suspicious activity reports and analyzing them further on, right? Whereas the lower probability alerts, which are not highly risk ranked, they would basically be closed, and again, the information would be passed on for improvement purposes. Here is very quickly the result or the outcomes. These are basically some of the points we discussed. Increasing true positives. So if you look at transaction monitoring, true positives are basically true positive. Again, just a reminder, is basically data that yielded positive results and it's actually true. So that's what we want. True positive is both the data is correct and the test result is positive of the correct data. So 5% of increase of true positives, which is great. And very importantly, 40% decrease of false positives. So you recall at the beginning, I was mentioning that on average is 20 to 30% reduction in false positives. Here UOB achieved a 40% decrease in false positives, which is great. In terms of name screening, as we're discussing, one of the main use cases for AI in AML systems and compliance systems is, again, a dramatic decrease of false positives for individual names, and then also very significant decrease of false positive for company names. Again, both name screenings are checked against, as I said, known lists or other contextual information that could potentially red flag whether that's an individual or a company. And an overall increase in operational efficiency of 40% was reached as a result of that. So I think this is very dramatic results, and I'm sure you probably have questions about this. So the second use case is DBS. So DBS, I think, similarly intended to automate some of their AML activities and move more into AI versus specifically current rule-based systems. They've implemented their own AML filter model, what they called the AML filter model, which would basically identify different behavioral patterns, indicators, or data related to suspicious transactions, and of course reduce the number of false positives. So as part of that initiative, they introduced the internal governance structures and measures, of course, because, as I said, AML sits on an infrastructure level next to core banking systems, and it's plugged into a number of product and data related systems that are working on top of core banking system. So as such, they came up with what's called Responsible Data Use Framework, or RDU. And DBS made sure that RDU includes, of course, stakeholders from different departments. So this is, again, a more holistic approach to developing AI and looking at AI as just a mere technology, but looking at AI from a business and as well as ethical and moral perspective, and consider that because of that, including making a committee that's going to supervise and eventually have an overview of an AI system deployed in a bank. So what did DBS do, right? So they built a training for approximately 8,000 alerts. So this was the training sample, and about 4,000 customers were analyzed over a period of 1 year. So you can see also the periods are quite interesting. That you would imagine that normal AI system, if it were a ready or almost ready product, you would have a couple of months. However, a bank like DBS took quite a while because this is fairly complex and it required about a year to train and analyze and customize their own AML system. And as they were aware of the different types of biases and potential risk factors, for example, to mitigate the model bias, so the AML model bias, the bank excluded data using training from testing data because this could have a data-related bias. Basically, if you're using the system that already was trained on specific data, including similar or same type of data, might be problematic down the road. So the backtesting stage involved, as I said, something around 4,000 plus alerts for about 3,000 customers over a period of 6 months. And finally, again, they validated it with another 4,000 or 600 alerts by another, again, similar number, 2,500 customers in separate periods of 4 months. So in some ways, I think DBS, if you look at this from this perspective, they did a bit of an approach where they try to systematically eliminate bias related to the model design, to algorithm design, because you're testing on different alerts and different customers, and you're also trying to eliminate human bias, right? So bias that could be inherent both in data as well as in the behaviors and the algorithms that are flagging out different suspicious activities. The RDU unit, so RDU, I remind you, is the responsible data use, right? So RDU framework that was all basically created as part of this AML initiative involved 3 stages. As you can see also, somewhat interestingly, the stages where basically the 3 stages of the responsible data unit would be first to ensure that AI compiled with fundamental legal compliance. This is basically the hygiene or the most foundational part. So it has to be compliant with legal compliance and other data quality standards. Second was a system that is instituted in DBS itself. That's what's called the PURE. PURE stands for purposeful, unsurprising, respectful, explainable. I think one of the keywords here is explainable. You recall we were just discussing how explainability is a big problem in a lot of AI systems, whereby AI ML system yields a result. For example, it rates a transaction as suspicious, whereby it might or might not be. If you knew the bigger context, it might not be suspicious. And a AI system in that case might not be able to explain why the result it came is that result. So the good thing here was that DBS from day one instituted a system whereby it would be explainable. The AI system that were to be implemented would be able to explain or interpret its own result in one way or another. And then last but not least, the framework, the AML framework, also made sure that AI and ML, well, AI systems conform to technical requirements specific to the DBS's governance policy, of course. Again, I think we mentioned, you can read this afterwards, but the idea here was that striking a balance is basically going from, let's say, a more rule-based system to having a fully fledged AI system in accordance to the RDU rules that we just highlighted, but also ensuring that this is not just left to AI algorithms to have a final say, but also having a human in the middle or human over the loop approach, which would allow some of the transactions which were, for example, suspicious or which would be sample transactions to also be validated, if you like, by human specialists. And as a such, that would be used to improve the model performance. Um, so ensuring good data accountability practices was one of the key goals, as you've seen, among others, based on the pure framework. This meant that one had to minimize, so the system was built in a way that it would minimize the data lineage, it would minimize any kind of a human cognitive bias, as we were just discussing about it. And of course, also minimize any algorithmic biases or risk factors that could come when you were designing such a system. I think the good point here also one of the interesting development was that DBS during the full deployment, initially at the test or sandbox level, and then eventually at the deployment level, they maintained the data mapping document that allowed basically tracing all data at any given point of time using the respective source system fields. And this way, DBS had a more contextual as well as a more holistic view of where the data came, not necessarily just the transaction, but all the relevant data as well. And I think DBS spent quite an amount of effort to try to tackle or mitigate the inherent bias. So inherent bias, guys, it's basically the bias that is inherent in both the algorithm design as well as the data that is there. So for example, DBS is the biggest Southeast Asian bank, and as such, their data is one way or another having a bias. Let's say, I mean, I'm not sure if it has, but it's possible that it has the bias specific, for example, to types of populations such as Singaporean or Indonesian or wherever DBS has the presence, has a big presence, such as, for example, also in India. Inherent bias will be to try and minimize the bias related to specific behavior, specific indicators that would be coming from those types of populations who are using DBS systems. And of course, and that's also inherent in the algorithm design itself, which is of course designed by companies, companies like Tukitaki, etc., who are also Asian. So also decrease or mitigate the risk in the algorithm design itself. So all in all, basically, I think they looked at around 17,000 alerts, trained on about 8,000 of those, right? And then tested, as I said, the second step, tested on about 4,500 of those, and then validated and analyzed, validated including humans, so human over the loop or human in the middle, validated around 4,600 of those alerts. So as I mentioned that like a bit earlier, it took DBS almost 2 years to develop and test the system, giving the team an intimate understanding of how AML systems have worked. Explainability was one of the main kind of metrics that DBS had in mind when they started off, and the good news was that because they tracked from the beginning the data lineage and the information full transparently offered information on contextual data, not just necessarily data specific to that transaction, but also some of the contextual data that went into the decision. Because of that, AI models were able to be more explainable or interpretable, if you like. And some of the risk rankings, so risk rankings that were being predicted or being given, they were the ones that could also be explained why they are like as they are. So among others, DBS implemented, as I said, internal controls to address risks involved in deployment AML systems. As I said, everything from trying to mitigate inherent bias in data and algorithms. Also, they documented everything. And everything, yeah, all the documentation was there. They looked at beyond, of course, documentation, as I was saying, they back tested, they validated everything, both algorithmically as well as with humans validating algorithmic outputs. Model metrics could be and are kind of fine-tuned based on additional information, additional inputs. And what's interesting here, so again, I think this also showed some of the limitations of rule-based models that with new AI, with new and updated AI systems, some of the rules could be enhanced or customized in a way to account for some of the other transactions that would otherwise be flagged down by the rules. And yeah, I think accountability, I think also a very important part of the success metrics that DBS had from day one on the agenda was that people were, I think accountability played a big role, not just in terms of reliability of using an AI system for AML inside the bank, but also in terms of having different stakeholders inside the organization to trust that the outcomes are reliable and to trust that the system can do what it does with full legal, regulatory, as well as considerations such as the pure framework inside DBS. So of course, because AML is quite a sensitive framework in that sense, because it has a significant impact on different types of transactions or data analysis. DBS understood that cases where the information on exact surveillance mechanism falls into different hands. So there was a full data protection system implemented to ensure that PDPA as well as other data privacy and protection rules would be fully considered. And I'm just conscious of time very quickly. So again, this is basically DBS. Again, link is here, as you see on the DBS is linked. To round up, kind of sum up, I understand this is a lot of information. There's a lot of heavy information. Just very quick kind of recommendations based on the initial conceptual analysis of ML systems that we had, especially from risk process and system risk perspective, as well as the case studies of UOB and DBS. So point number one, as a recommendation number one, would be to institute a strong governance system. As you've seen very obviously from UOB and DBS cases, a good starting point for developing an AI system for AML would be to obviously use and leverage the existing model risk management approaches. Second would be to define scope or objectives of the success from the outset. So again, as you've seen with cases of UOB and DBS, both of them had very specific outcomes in mind, among others, for example, improving the false positive ratio or decreasing it, if you like, and improving operational efficiency. And of course, in a context of especially Singapore related data, adherence to fair use of personal data and legal rights to explanation, right? Not just PDPA, but generally the explainability problem is a major issue to be tackled again from day one. And I think very important was to remember that again, AI here is used as a system to improve specific business metrics, such as I said, a reduction of false positives on the AML system, improvement of true positives, and name matching related analysis as well. Making the design more transparent, I think, can probably emphasize this more than this, but making it such that the design and the data that is considered in different decisions for AML is transparent and it's available, so that different stakeholders in the bank can actually look and understand why the decisions were reached and how. Focus on data inputs, also very important, because as mentioned earlier, many banks and insurance companies jump on AI train, but they forget to consider things such as data availability, structured data, ideally. And important factor there is that once you have the data, there is always some sort of a bias or some sort of a risk factor related to data. Very important to try to eliminate it. As you've seen, DBS has gone to a large extent, to a large effort to really eliminate it as much as possible. Apply robust testing and validation. Again, I'm not giving any specific names here, but you've seen some of the names and some of the methodologies earlier mentioned. Always go with approach of kind of back testing on historic data and compare the results of your algorithm's performance with the historic performance. This is because it's a real historic data. And then, of course, the second step would be to back test to test it in some sort of a sandbox or pilot environment on a smaller sample, or do it 2 or 3 times, a bit like DBS did, to make sure that as much of bias both in data, in algorithm, as well as decisioning is not there anymore, is removed. And last but not least, to implement, to engage early, as it says, engage early, deploy incrementally, and review regularly. So there's a nice little expression. But the idea is that you are going to disrupt, because normally a lot of the systems are rule-based or human-based, using technology to kind of automate or to streamline AML or compliance-related data analysis requires or necessitates, if you like, a disruption of current systems in a bank or an insurance company. So you have to consider different operational risks as well as other risks that are inherent in this process. And it's very important that you don't necessarily trust the system, but more you implement the system, customize it, do the feature engineering part, run a historic test, but also have humans who would validate at the initial stages that both the back test as well as the pilot or trial stage of outcomes from the AML are as they are supposed to be. And that's it as far as the kind of 6 main steps. And I think a couple of frameworks that we have seen implemented in Singapore and the region are some of this. So Napier is very popular. Tukitaki, that was the one that the RegTech company that UOB implemented. GetID.ee, regtank.com. So some of the systems are also implemented in banks and insurance companies in the region. And yeah, and I'll leave you with basically a quote. I like this quote: "He who thinks he can and he who thinks he cannot are both right." And I'm conscious we went a little bit over time, but let's take maybe 1 or 2 questions. And guys, please feel free to connect with me and follow up with questions that unfortunately I might not have time to answer a lot of the questions, but yeah, feel free to follow up with me afterwards on this.
That's all for today. Thank you so much. Do stay connected with us via our LinkedIn or via our website. Thank you once again for joining us. And till next time, goodbye.